Welcome friend. In this video we are see the operator relation. Friend, we know that we have in the previous videos seen the forward difference operator, displacement operator, and we are also uh, known about the Taylor's theorem, and which contain the derivative. So, in this video we see what is the relation between this delta forward difference operator, derivative d and derivative, and for this derivative we use the symbol d and the shift operator e. Y x plus h, y at x plus h equal to y x plus h into derivative of y x plus h square divided by 2 factorial, second derivative of y x function plus here h raised to n, last term nth derivative of y x. So, it contains infinite terms. Now, we can write it as 1 plus h into d plus h square d square divided by 2 factorial plus h raised to n d raised to n divided by n factorial plus these are operating on yx. But this is nothing but the expansion of exponential series, that is e raised to h d operating on yx. Again this yx plus h we write it as e yx, h is added. So, e yx equal to e raised to h d yx, and hence we get a beautiful result between this shifting operator and derivative e equal to e raised to h t. But what is e? E equal to 1 plus delta. So, we get this operator relation between this operator. Okay. Now, if for this two, if we consider the logarithm, that is h d equal to log of e base e 1 plus delta, then its expansion is delta minus 1 by 2 delta square plus 1 by 3 delta cube minus like this. Now friend, here we define the backward differences, and we denote this by symbol. This is a NEPLA, it is called as a NEPLA, and this is a f of x equal to f of x minus f of x minus h. Since we are considering the difference from the given term and its backward term, therefore it is called as a backward differences. So, NEPLA of f of x plus h equal to f of x plus h minus its backward term, that is f of x. Laplace of f of x plus 2h equal to f of x plus 2h minus f of x plus h. Laplace of f of x plus 3h equal to f of x plus 3h minus f of x plus 2h. Now, Laplace square of f of x plus h equal to, it is 2 times Laplace f of x plus h equal to this is Laplace of f of x plus h. F of x plus h is f of x plus h minus f of x. So, this is equal to Laplace of f of x plus h minus Laplace of f of x, and this is f of x plus h minus f of x minus f of x minus plus f of x minus h equal to f of x plus h minus twice f of x plus f of x minus h. So, in this manner we can calculate the other powers of Laplace. Laplace of f of x plus h cube equal to, this is Laplace square of f of x plus h minus Laplace square of f of x, or in general Napla raised to n of f of x plus h is nothing but Napla raised to n minus 1 f of x plus h minus Napla raised to n minus 1 of f of x. So, this is our backward difference operator. Now, here we have defined the relation between the derivative and shifting operator. We use that operator e equal to e raised to hd. So, therefore, e raised to minus 1 equal to e raised to minus hd. Okay, and just we have seen that Napla of f of x equal to f of x minus f of x minus h. So, this is f of x minus e raised to minus 1 f of x equal to 1 minus e raised to minus 1 f of x. So, we get the relation Napla and e shifting operator equal to 1 minus e raised to minus 1. Napla equal to 1 minus e raised to minus 1 means e raised to minus hd, or e raised to minus hd equal to 1 minus Napla. And here if we take the logarithm on both sides, minus hd equal to log of 1 minus Napla, or hd equal to minus log of 1 minus Napla, and this is equal to Napla plus 1 by 2 del Laplace square plus 1 by 3 Laplace cube plus like this. So, this is the relation between the another operator, backward difference operator, and forward difference operator and the derivative. Thank you friend, thank you for watching the video.